if you are letting AI agents touch real tools. The scary part is not that they might sound wrong. It is that one messy prompt can start behaving like a shell command. Microsoft just called out remote code execution risks in AI agent frameworks, and the useful lesson is very practical. The next underdog advantage is not a bigger model, it is the boring guardrail between words and actions. Here is the one mechanism to understand. A normal chatbot gives you text. If it misunderstands you, you get a bad answer. An agent is different. It can call tools, it can read files, it can run scripts, it can pass your request into a framework that eventually reaches a command line, a browser, a plugin, or a backend service. That is powerful. It is also the new weak seam, because prompts are no longer just instructions for a model. In an agent system, prompts can become inputs to real software, and if the framework stitches those inputs into commands too loosely, a sentence can cross the line from request to execution. That is why this story matters more than a typical vulnerability post. It is not just saying, patch this one bug and move on. It is showing a design pattern that teams are going to keep tripping over. The old software security question was, can an attacker send data where code is expected? The new agent security question is, can an attacker write words that eventually become an action the system never meant to approve? Think about a support agent. A customer pastes a weird message into a chat. The agent summarizes it, routes it, maybe opens a ticket, maybe queries an internal tool. Think about a coding agent. It reads a README, a GitHub issue, or a generated task. Then it decides which command to run. Think about a finance or operations agent. It pulls data, fills forms, creates records, maybe triggers payments later. None of these systems feel dangerous when they are demos. They feel helpful. That is the trap. The underdog team that wins here is not the one that lets agents do everything fastest. It is the team that treats every tool call like a border crossing. At that border, 3 boring checks suddenly become valuable. First, separate prompt text from executable parameters. Do not let natural language slide straight into shell strings, database queries, file paths, or API calls without structure. Second, force narrow permissions. The agent should not have a master key just because the demo looked smoother. It should get the smallest tool, the smallest folder, the smallest account, and the smallest time window that can finish the job. Third, make the action visible before it matters. A human should be able to see, approve, or roll back the step that can delete, publish, spend, email, deploy, or expose data. That sounds like friction. But this is the practical edge. As agents spread, speed will get cheap. Everybody will have a clever assistant that can draft, click, search, and call APIs. Trust will not be cheap. The companies that can say, our agent is useful, and here is why it cannot casually turn a poisoned prompt into a real command, will move faster with less fear. The small team can use this as leverage. You do not need the biggest model budget to look serious. You need clean tool boundaries, logs people can read, permission scopes that make sense, and a habit of asking, what would happen if this prompt were hostile? Here is the simple checklist. If an AI agent can touch a real system, ask 4 questions before you trust it. What tools can it call? What exact data reaches those tools? What actions need approval? And what is the blast radius if the prompt is malicious, confused, or just weird? That is the shift. Agent safety is not a philosophical debate anymore. It is an operations checklist, and the person who learns that early becomes the calm one in the room. Not anti-AI, not reckless either, just prepared enough to use powerful agents without handing them the keys to the building.